All right, so we're going to talk about while loops today. While loops are just another way of repeating information. They work a little bit differently than a for loop, but essentially they accomplish a similar outcome. We did if statements and Boolean functions and talked about conditionals. While loops work with those conditional statements. So our for loops, we pretty much knew what we were going to do. We had a range, we had a starting point, and an ending point. While loops are going to give us the option of do until something happens. And we may not know when that until is going to hit us. So we use conditional statements. We're going to basically base it on whether or not it's true or false. The test is true or false. I don't know exactly why the random module comes up in this slide deck when we had to use it in the last project. It's a little out of sequence, but we're going to talk about random a little bit. But you all should be experts at it at this point if you did part 3 of the last project. So the API link for random is here. I need it works this time. So the link actually works in the slide deck this time. So you can look it up and do all sorts of great things with random numbers. When you do work with random numbers, remember you have to import the module before you can use it. I did notice in some of the last assignments that import statements are turning up in weird spots. I did have one assignment recently that had 3 main methods in it. You're going to notice that your grades are starting to get dinged for things like, oh, extra main methods, or your import statements are not at the top of the page. These are style points. Does it still work? Yeah, but it's really bad code. It's really not the preferred way to do it. So we're going to try to unteach some bad habits and start enforcing some good habits, because style is definitely a thing. So we want to remember that randoms, you can get a random number inside of a range. So you have a starting point and ending point with a random number. And you also could have an optional third value in there with a step, how much different you want it to be. You want it to jump at least 2 or 3. We did this in some other functions before, right? Yes, sir.
So on the project, I used the add range thing, but I didn't use the step, and it's still.
You don't have to use a step, it's optional.
So
That when you see a parameter with these square brackets around it, it's optional. So you can do the same thing and say, what else did we use it for? Oh, my brain's drawing a blank. Oh, looping. When you're doing loops, you can, instead of going up by 1, you can go up by more than 1, right? So you can do, but if it's in square brackets, it's optional. You can use it or you not use it. Completely up to you. If you don't use it, then it's just the next random number. If you do use it, it's going to skip over some random numbers under the whatever the step is. It gives you honestly, it makes it a little bit more random and gives you a bigger range usually between the numbers, depending on what the random number was. But random numbers, honestly, are not really random. They are calculated using a formula based on the clock speed of your computer, but you will never know exactly what the clock speed of your computer is because it moves in nanoseconds, and most humans, I'm going to qualify that just because there's going to be some weird savant somewhere, can't keep up with what nanosecond they're on, right?
what if you like overclock?
then it will probably burn up because you have exceeded its tolerances, and it will run faster for a short period of time, but you're probably gonna burn your computer processor up faster than you normally would. Do people still overclock computers? Anyway, so we've done function calls, loops, and conditionals. We're gonna throw this extra while loop in. Conditional loops are while loops, counting loops are for loops. For loops are always counting up to something or down to something. While loops are gonna test true or false. So some real life examples of loops. You should continue eating until you're full. Once you're full, you should stop eating. Not everybody follows this in real life, but while you don't like the current radio station, you should press the button to scan up to the next radio station or down to the next radio station. If you're in the car with me, you get 3 tries before I lose my patience with you, and you have to pick a radio station. I'm old. I still listen to the radio.
Sirius XM still?
Nope. Radio.
That's technically the radio.
I listen to free radio. I don't pay for satellite subscription.
That's my bad.
Old folks. Us old folks. We listen to the commercials and everything. Go figure. So while you don't like the radio station, press scan. While there's different ways to read it, to write it. You can write it a true or false statement. But so you also notice that in your descriptions and your directions, it's telling you to use doc strings. Doc strings are indicated with 3 quotation marks to begin them and 3 quotation marks to end them. They can be multiple lines long that start with 3 quotations and end with 3 quotations. They are almost exactly like comments. The computer will completely ignore them. They're mostly notes to yourself or to other people. Doc strings were created where you could start describing functions and what the program is doing. And then when you finish writing the code, it will actually gather them up into a documentation file. So all that documentation you read that comes with software is written very much like an engineer wrote it, and it's written in computerese. Probably started off in doc strings and were gathered up, and it's like got parameters, what's necessary. All that API stuff probably started off as doc strings. You notice every function has a little bit of a description and some parameters and stuff. That's how they started. I'm not going to grade you down if you just put regular comments in. Doc strings, comments, same difference from what our purposes are here, because you guys are never going to print any documentation. But be aware that they're there. It's much easier to me to use doc strings in Java than it is in Python. That's just personal preference. So in this particular example, we're defining a function that's going to scan from radio station, right? So the current radio station is going to call a function to get it. While we don't like that radio station, we're going to press the scan button, and scan does whatever scan does. When we finally find one that we like, we'll stop.
Is the scan function built into Python, or is this just something?
Now, this is just an example.
I was.
This is all fiction. You would have to define all these extra functions. So we did loops with our turtles. This is a square without a loop. This is a square with a loop. We used a for loop because a square has 4 sides every time. So we know we're counting 4. Right?
Mhm.
A while loop doesn't make as much sense here. Because we know exactly how far we're going. Could we write it in a while loop? Yeah, we could say while x is not equal to 4, and then count up, count up, but it would take more steps. So while statements are going to have the keyword while, whatever the condition is, and a colon, like your if statements. If condition colon, while condition colon. The difference is in the for loop, we set up an index and it automatically started at 0, I, and then I incremented by 1 unless you told it to do something different. The while loop doesn't do that inside of itself. So if you're trying to keep a counter in a while loop, you have to set up the variable before the while starts and tell it specifically inside the while to increase or decrease it. So in this case, we set up a variable called loop. We set it equal to 0. We also have a variable called sum, and we set it equal to 0. Right? While loop is less than 5, I'm going to take sum and add 2 to it. Right? Make sense? And then I'm going to add 1 to loop. Yes.
So you said you define them outside of the loop. Now, it's obviously different, but in the project, when you use a for loop, you had to define the RGB inside. I know.
Yes, because you want each triangle to change.
Yeah, but that's my question. Like, how does defining it inside the loop? Like,
Okay.
it would equal 0.
So if you did not define it outside of the loop,
It's just like,
all of the triangles turn whatever random color it was, right? So if you want to carry that value outside of the loop, you do it beforehand. If it's something that needs to change every time the loop runs, do it inside the loop. So remember we talked about scope. If I defined loop and sum inside of while, that would reset to 0 every time it ran. So you never would tally anything. And in this case, since loop is the part of the test, you would never actually stop because loop would never get greater than 1. Right?
so they always restart at 0 every time.
If they were inside the loop, they would.
Yeah.
So I prefer for loops when I'm coding because all of it's done on one line and I don't have to worry about whether I did the loop counter at the same time. Logically, a while loop is used if you don't know where you're stopping at or you aren't positive. There's some test that has to run. For loops are used when you're counting. Yeah.
So that would run like 5 times since it's adding 1 to loop every time.
I don't know. Let's see. So if loop is 0, it's gonna run for 0, gonna run for 1, gonna run for 2, gonna run for 3, gonna run for 4. When loop is 5, is it less than 5? So it doesn't run the 6th time. Yes, it runs 5 times. The index of the value in loop is 1 less than 5 because of the starting counting of 0.
So when you say like you use it when you don't know when you're gonna stop, but when you say if it's less than 5 and hit 5, it stops. So it's like what's the
But it doesn't ever hit 5
Never hits 5.
unless it was.
Okay,
less
this
than-
example could be done as a for loop. So let's say I have a whole telephone book worth of people I have to go through. I want to run my loop while the last names start with W. I have no idea how many people have a last name that starts with W without going and counting them all. Right?
They hit me.
So, no, I love that you keep asking questions, because if you're confused about it, somebody else is probably confused about it too. Except for your buddy next to you that likes to just, give you a hard time, but that's okay. So this was what it would look like as you do a for loop. Yeah, if you knew you were only gonna do it through 5, I probably would do it in a for loop. Because you're counting 5. But if it's something like thousands of records and you don't know how many records you're dealing with, then I would use a while loop. So here's another example of a while loop. While is in screen turtle window. So this function actually exists. It's one that's written in the turtle module. And it tells the turtle whether or not it's still in the window you create. Because if your turtle goes over the boundaries of your window, you can't see it. So we should tell the turtle, or it tells the turtle, to stop when it gets to the edge. Which is a good thing, because we don't want our turtle lost in cyberspace, right? We'd hate to have some search party out for our turtles. So this one is going to, this function from the turtle module returns true or false. Is it in the screen? If it is, it returns true. If it's not, it returns false. And the first time it goes 1 pixel outside of the screen, you'll still be able to see most of the turtle, but its nose has gone across the edge. It automatically returns false. We're going to set up a value in here called coin. We're going to use a random between 0 and 2.
What does that do?
It gives you a random number.
Between 0 and 2?
So it's a 1 or 0. Right? So it's like flipping a coin, it's either heads or tails. But you don't, this one, the computer decides whether it's heads or tails. You don't. The computer does. You don't know if it'll get 1, you don't know if it'll get 0. You'll never get 2 because it doesn't include the 2.
Okay, that makes sense.
So if it's 0, the turtle's going to turn left 90 degrees. If it's 1, it's going to turn right 90 degrees. So guess what? We're fixing to write some code where our turtle is going to randomly move around the screen and draw a pretty picture. It's cute, it'll work. But we don't know how many times the turtle's going to move when we write this code, because the turtle's going to randomly turn right or left and bounce off the edges until it leaves the screen. Okay?
What happens when it leaves the screen? You said it says true or false.
When it leaves the screen, everything inside of here stops running because it's false. So the while loop stops. So your turtle's going to stop on the edge of the screen. Works when it wants to. It doesn't look good. This is an infinite loop. Why is this an infinite loop? This loop never stops.
The value of loop never changes.
Because the value of loop never changes. We left that line off. So loop is equal to 0. 0 is less than 5. We didn't put a line in here telling it that to increase loop. So it never stops. Infinite loops are a lot of fun. Sorry, Kevin. Infinite loops are not a lot of fun because you sit there going, why is my program still running? If you are really talented, like I was years ago, getting my computer science degree, you can shut the whole computer down when you're running out of memory.
Well, I remember when you and the TA were talking about that.
Yeah. So if you're doing a big enough program and you're running it long enough, the infinite loop will eventually run your computer out of memory and you'll get the blue screen of death. It would take a very long time with these small Python files for that to happen. Back in the day, God, almost 30 years ago, when I was getting my computer science degree, okay, we'll say 25. You used to have to send all of your code to the mainframe, the student mainframe or the student server on campus to compile. It didn't compile locally. And, you know, if you were pretty brilliant or pretty stupid, one of the two, you could crash the whole student server with an infinite loop. And if you did that the night the project was due, your classmates hated you. Because they couldn't do anything if the server was down.
I would so do that if I did that. Back in the day.
You so would not. So the good news is you're only gonna affect yourself. And with the Python IDE, if it's just running and running and running and doesn't stop, you can always send on the X and close the window and it stops.
It'll say you have it in-
Yeah. The IDEs have gotten much more advanced. They'll tell you if it detects an infinite loop.
So you
It's a
try to-
great thing for you guys.
pretty much.
Just be glad you're not programming in the dark ages of programming like some of us. So, infinite loops are bad. So be aware. If you do get the error for infinite loop, the first thing I would check is see if you are updating your index or your counting variable. The second thing I would check is to make sure you have your less than and your greater than signs correct. Because if you had flopped that sign over to greater than 5, and it started counting at 5, it would go forever too. Does that make sense? So those are two of the big possibilities for an infinite loop. You are not increasing or decreasing your loop counter, or you've used the wrong sign. It's also easy for your loops, while loops to go one further than you wanted them to do with that whole less than or equal to thing. So be careful with that. So while loops are really great for validating input. So if I ask the user to give me the example that makes sense. If I was asking a user to input a price of a car, and they gave me a negative number, that doesn't make sense, right? Because prices shouldn't be negative. So what you can do is you can have an input statement, gather that information, and then immediately run it through a test to see if it's true or false, or if it meets the parameters. So in this case, we want money to be over 0 or above, right? So we could have a while loop that says while input is less than 0, ask the user to input again. And it forces them to keep giving you numbers until they give you a valid one. I'm sure some of you have seen this on menu structures, on phone systems, press a button, those sort of things. Until you press a valid number, it just repeats the menu structure. press 1 for help desk, press 2 for billing, press 3 for something else. Press 0 for the operator, but if you press a number that wasn't listed, it just repeats the menu to you again, because it assumes you didn't hear them correctly. Now they're voice activated and they can't ever understand what I'm saying. So whatever option I was supposed to say is obviously not in Southern. So I find myself yelling at these things a lot.
I just pass them out and then I hang out.
While statements are also good for menu structures. And to, you know, like if you're playing a really low-end game and you're doing things based on key presses, and you could run a while loop that will keep asking you for input until you give it the key sequence that quits the game. Maybe I haven't played Clash of Clans, so
Yes, that-
my children play it, but I don't.
I got one.
But so, like with the phone system, again, until you press 0 or 9 to exit, it's gonna keep asking you questions, right? So that's what while loops are good for. They're waiting for something to fail before they stop. Would you like to play again? Yes or no? You put in yes, it plays again. You put in no, it shuts everything down and moves on. Not that I'm fixing to make you write a really simple guessing game. Hey, I'm fixing to make you write a really simple guessing game.
I have a question.
Okay.
It's kind of a real.
Yes, you should wait.
It's so good. I didn't.
So you can actually set your variables equal to true or false. And for those menu structures, like you want to play again, you probably would set it to true where you would play the game the first time. Right? So while loop, in this case, loop's going to evaluate the true or false. Prompt the user for some value. If the value is within the range, let's say I was looking for a number between 0 and 100. If the input's between 0 and 100, I say false because I don't want to ask them again. Right? And I move on. If it's not between my range of 0 and 100, I set it equal to true, and we prompt the user for more input.
What is the point of the loop equals true at the top?
Because while it's true, it's running. When it turns to false, it stops running.
I can ask you it.
So here's a less theoretical example. If value is equal to 0, loop is equal to true. Value, we're going to go into our while loop. It's going to run at least one time because loop is set to true to begin with, right? Right? We were going to say type of input to enter a number. We're going to convert that input into an integer instead of a string. If the value is greater than or equal to 0, we're going to change loop to be equal to false. Else, we're going to print invalid number. Please enter a positive number. And the loop's going to run again. And prompt the user for a number. So we validated the data. If it was true, we continued on. If it was good data, we continued on. If it was bad data, we gave an error message to the user telling them what they did wrong because we're nice that way and we don't want them to just guess why they got the prompt again. And then it jumps back up here to the loop and it runs it again. And it keeps doing that until the value is greater than or equal to 0. Once it's greater than or equal to 0, it changes the loop variable to false. Now, while false won't work, it stops pumping music. All right, guys in the back, y'all following? Good.
I'm following, I'm sorry.
Sentinel values are often used in whiles. Sentinel values is something that is so far outside the range that it can't accidentally be put in. So if you put in negative 999, that could be a sentinel value. And you could use that as your loop test or your quitting condition, right? You, if input equals 999, set your loop variable to false, and you're done, right? Otherwise, your loop variable stays true, and it just keeps going forever. Yes or no, or play again. So in this example, it uses a sentinel value. Loop is equal to true, and it stays equal to true until that if statement changes it. So if the user never enters negative 999, just keep playing until your fingers fall off.
The Wi-Fi is so slow. I can't.
Yeah, well, pounding on the keyboard is not gonna make it go any faster. Yes, ma'am.
So
Here's my
like,
question.
it's like.
All the users. And if you get it
Yeah.
wrong, it's gonna be a-
Or you can have a sentinel value that's yes or no.
Please
Or
tell
if,
me.
do you wanna quit? Yes. Or no.
Or
If you say yes, then it quits. It's just something that is defined that would not accidentally be pulled.
might as well quit college.
So we're gonna do a number guessing game for assignment 6. It's gonna have a lot of if statements in it. And a while loop is gonna make you keep guessing until you get the right number. We're not gonna work on it today, because obviously we're gonna do the lab as the first. The guessing game though will look something like this when you run it. You're gonna have directions at the top, because you want to give your users the directions of what they're doing. You're gonna ask them what their first guess is. If it's incorrect, you're gonna put up incorrect guess again. If it's correct, you want to congratulate them on guessing correctly, and then ask them if they want to play again. Right? So it's a while loop. While guess is not equal to answer, keep asking for more. Random numbers now making more sense why in this unit, right? We're gonna use a random number generator to decide what that value is gonna be that we're looking for. We're gonna use if statement to check to see if it's the number or not.
That actually does. It's 'cause I'm awake.
Don't give him more time. Lab 6, we are going to start on. You're welcome to get started on it if you want to without me. Like I said, be the first thing we do Monday when we get back from our long weekend. I will run through it just like I do any other time. If you show up here on Wednesday in person, you will be all by your bones.
Luke,
Don't come Wednesday, sleep in.
or you told us about
Did not say that.
not me.